Hello everyone, it's Homer White coming to you from the essentially abandoned Asher Science Center in the Math Lounge with the next installment of our explorations of the ggplot2 package. So in this installment, we're going to leverage our knowledge of the grammar of graphics to dig deeper into how that grammar is implemented in the code for ggplot2. So make sure that you've attached the packages that we're going to need today, ggplot2 and beginning computer science with R. So what makes the frame? So when you build a data frame, you start with the ggplot function. And that function takes a data frame as the argument to its first parameter, data. So if you were to run just ggplot, data is the M111 survey data frame in the BCSCR package, this is what you're going to get. And you're like, well, that ain't nothing. But something really important has happened. By setting data to M111 survey, then all the variables that you're going to need for your plot are going to be made accessible to you by their variable name within that data frame. ggplot's going to know to look inside M111 survey for the names of variables. Now, right now it is a blank, so how do you add to it? Well, if you take advantage of the second parameter in the ggplot function called mapping, and if you give it as arguments the result of a call to the AES function, short for aesthetic, you can set up a frame by saying that X position shall be mapped to fastest, Y position to the student's GPA, and you'll get that intermediate plot that has, again, no visible glyphs, but at least now there are X and Y axes correctly labeled for the data. Now, most people, when they are setting up the frame for their plot, are not going to name the parameters. They're just going to put the arguments in the right order. So you'll see ggplot, name of the data frame, comma, S of what you need to map for the frame. Now, a call to ggplot produces a ggplot object. And the plus that comes after it here passes that object on to the next ggplot function. And there is a ggplot function called labs that has various parameters of interest. The X and Y parameters let you give better axis label names than just the name of the variables like fastest and GPA. You put them in quotes, and it's always good to give a good description of your variable and to give units if possible. And similarly, the y-axis is now going to say grade point average instead of GPA, and it's more explanatory. You can add a title to your graph in quotes, and you can even add a subtitle. This one is so long that I'm pasting pieces of it together with the paste zero function. Now, ordinarily, you're not going to add on labels to your plot until you've looked at the plot to see what the pattern is for the plot. So I kind of have just some placeholder text right now for the title and the subtitle. I just want to show you the effect. And so if you ran all this, then notice the title's a bit larger type, the subtitle's a bit smaller type. And we've got the nice names for the X and the Y axis. For a finished plot, you'll always want to make use of your X, Y, and title and subtitle if necessary at the end. Okay, let's get into the glyphs again. So when you add on a glyph to a plot object, you'll do so by means of a call to a function that in ggplot2 always has the form geom underscore and then the name for the type of glyph you want. So for scatter plots, geom underscore point. For bar graphs, geom underscore bar. For histograms, geom underscore histogram. Density plots, violin plots. Geom jitter is going to be used to make those jittered individual points that, that are jittered so they don't overplot each other. And geom rug is going to make those rug ticks we saw in the last screencast. There's a great many more geoms available in ggplot2. We're just hitting some basics. So the way you add those glyphs on is you take your initial plotting object and you plus it into a call to geom whatever glyph you want. And so the result of this call would be that basic scatter plot where all the points are black and all the points are round. Now let's think about implementing aesthetic mappings other than the ones that make the frame. So the way that's typically done is in your call to the geom in your call to the glyph creator, throw in a call to AES where you map a visual property that glyph recognizes to a variable in the data frame. Okay? Now geom point recognizes the aesthetic color because points can have colors. And this is saying we're going to map that to the sex of the individual, male or female. So it's typical to put that call here inside the call to geom point. Strictly speaking, you could put it up here along with the other aesthetic mappings that made the frame. Because when geom point gets that plot object, it'll look at it and say, oh, there's an aesthetic color to sex. I recognize what color can do, and it'll work things out the same way. It's just a little bit more of a convention to call your aesthetics kind of at the moment you need them for a particular geom. So that's how we got the color-coded scatter plot that we saw in the last screencasts. It's after you see your basic plot and learn what you learn from it that you would construct an appropriate title and an appropriate subtitle if you think you need it. And so typically people will tack on the labs at the end because it's the last thing they thought about when they were making the plot. So this function call produces the finished product. Now I want to make it very clear to you there is a distinction between aesthetic mappings and fixed properties for glyphs. Like suppose that we wanted all the points on the scatter plot to be blue instead of that default black color that is given. You set up your frame and then you add on the point glyph, but instead of saying S, color gets mapped to something, just say color equals whatever fixed color you want all the points to be. So that means color will not be an aesthetic. It doesn't vary from one student to the other. It doesn't vary with the data. Here's the result. So typical fixed properties when you're making a scatter plot is that you might choose the color for yourself. You might choose the shape for yourself. If you were to Google, R shaped for points or something like that, you'll come upon websites that show you how to make different shapes. And basically there's 25 different possible ones, like 1 to 25. It turns out that 22 makes solid squares if you're interested. You can get triangles and stars and all kinds of other doohickeys for your points. The size for the points, the default is a 1, so you can make larger points by choosing a size bigger than 1, smaller by choosing a size between 0 and 1. So let's look at how you would use ggplot2 code to make more types of graphs. If you want density plots, say a density plot of the fastest speeds ever driven, set up your frame. Notice you're only mapping x to fastest. You leave the y-axis for r to work with in a density plot. And then geom density. And notice I have a fixed property here, fill equals Burleywood, to get the area underneath the density plot to be filled with the Burleywood color. If you want to do layering, which means presenting more than one type of glyph on a graph, then all you got to do is use the plus sign and throw in another glyph. So geom rug. And here's the result. Now there were 71 students in this data set. It doesn't look like there's 71 individual tick marks down here for the rug. Looks like there's a lot fewer. And what's going on is that a lot of students reported driving the same speed, so they're over-plotting each other. That's something you want to think about when you make rugs. How might you deal with that problem? Well, what you could do is create a new variable for your data frame. Check what I'm doing here. I'm first finding out how many rows there are in Math 111 survey. There are 71. So the n's going to be bound to 71. And then I'm saying, hey, inside a Math 111 survey, let's create a new column. It's a little dollar sign. It's going to be called jittered speeds. And what it shall be is the result of taking the fastest variable in M111 survey and adding on the result of a call to RUNIF, where I get 71 random real numbers between -1 and 1. And so what I'm doing is randomly adding on a small number to each speed. And then I make my plot. So I set up my frame as usual, I set up my density plot as usual, and I set up my rug. But I say, hey, instead of the x position being mapped to fastest as it was originally, I'm going to change that up on you, Mr. Rug. I'm going to aesthetically map x position to the jittered speeds that's inside of M111 survey now. And then some labels to make it nice. And since each speed has been jittered left or right a tiny amount, they mostly don't overplot each other, so you get a much better sense of where the students are and how they really are crowded near speeds of 100, and that's why the density plot is high there. Let's try some violin plots. So for them, the correct geom is geom violin. Now when you're setting them up, you're going to have to make your frame x-axis maps to the categorical variable that you're grouping by, y maps to the numerical variable that you're actually making the violins out of. I'd like all the violins to be colored Burleywood on the inside. And I'm going to do some layering. I'm going to throw on some individual points that represent the actual students, and they're going to be jittered to the left and right a little bit. Talk about the width parameter in just a moment. Here's a nice here's some nice labels for the x and y axis. So we see the result, and notice the jittering. It's not too wide. You know, the the points are jittered to the left and right. They're still at roughly the same speeds that the student drove, but the jittering to the left and right is enough to make sure they don't have much chance of overplotting. Now, by default, the jittering would go to the very boundaries of each group. So like there's a boundary halfway between front and middle. There's a boundary halfway between middle and back. And the left and right would take you straight to those boundaries. But when I set width to be a number smaller than 1, I get a narrower jittering. And I find width equals 0.25 tends to work pretty well with these violin plots. I want to talk about faceting. So ggplot2 has 2 functions for splitting a plot into its facets. There's facet grid and facet wrap. So we'd like to investigate how to do faceting, but at the same time, I'd like to teach you about an interesting new data set. So you're going to need the library Mosaic Data. And there's a data set in it called Rail Trail. So I'm going to go ahead and head back to our studio here and do a library Mosaic Data. And some help on Rail Trail. And how about a view of Rail Trail as well? So when you read the help, you'll learn that the data are taken from one of those old railroads that's been converted into like a walking and bicycling trail up in Massachusetts. And every row is a day, somewhere between April 5th, 2005 to November 15th, 2005. 90 days, 90 rows. Sure enough. And there's a lot of information about each day. The high temperature, the low temperature, the average temperature each day. And then there's 3 variables that are 0, 1 variables, and they tell you whether or not it's spring, 0 not spring, 1 spring, whether or not it's summer, 0s and 1s, whether or not it's fall, 0s and 1s. And some information about the cloud cover and how much rain there was that day. Volume is how many times the little clicker at the beginning of the trail was triggered by someone walking or riding by. So it roughly measures how many people used the trail that day. And weekday is whether or not it was a Monday through Friday or a weekend. Well, actually looking at the help, so true stands for a non-holiday weekday. False would stand for a weekend or a holiday when it occurs during a day of the week. And lastly, there's a day type, weekday or weekend. So slightly different logic on that, Monday through Friday versus Saturday, Sunday. Okay, heading back to the slides. Our aim is going to be to study how the season, spring, summer, or fall, and the time of week, so weekday versus weekend, how do they relate to volume, which is the number of people who use the trail on a given day. So 3 variables being studied together. But if you think about it, the season is not recorded in one single variable. Back in Rail Trail, there were 3 different variables, one for spring, one for summer, one for fall. So we're going to have to create one new variable with the values spring, summer, and fall. So we'll have to do a little bit of wrangling. Going to figure out how many rows there are in Rail Trail and call that n. And I'm going to set up a little empty character vector that's in long, and it's called season. And then I got a little for loop where I'm going to store some things into that results vector season. For I in 1 to n, if rail trail spring in the ith place is true, then I'm going to put the string spring into season at the ith place. Now you might be like, whoa, wait a minute. Spring was like ones and zeros. How could it be true or false? Well, if you put a numerical variable into a Boolean condition, then R is going to have to coerce it to a logical. And so it coerces everything that's not a zero into true. It coerces zeros into false. So if there's a 1 at that spot, then you get inside this if statement and you put spring in the ith place. But otherwise, if there's a 1 in the summer spot, then you'll put summer into season at the ith place. Otherwise, if there's a 1 at the fall spot, you'll put fall into season I. So that's one way to gradually build up a character vector that has the values spring, summer, or fall as you want. And then you say, hey, I'm going to make a new variable in Railtrail called season, and it shall be the result of taking that character vector season and making it into a factor where the levels are spring, summer, fall in that order, rather than in the default alphabetical order that you would get by making a character vector into a factor. So when you try all of that, then you're almost ready to go. I'd like to get some nicer looking labels on the graph I plan to produce, so I'm going to do a little more wrangling. I'm going to create a new variable called weekday in Rails trails. And the way it works is if rail trail weekday is weekday, or if rail trail weekday is true, then I'm going to put Monday, Friday. But otherwise, I'm going to put Saturday, Sunday. All right, ready to try to make a nice plot to examine the 3 variables together. It's basically going to be density plots, but I'm going to produce one for every different season and for every different type of day. So I start off with the rail trail data aesthetically mapping X to the volume. I asked to make density plots that are burly wood in color, but I head to Facet grid next. And what it goes inside is a little formula where the variable that changes along the columns of the grid is season, and the variable that changes along the rows is weekday. Let's see the effect. So we have spring, we have summer, we have fall as you go down, as you go down the rows, the first variable changes. And then as you change the columns, you're changing the second variable, the one after the twiddles. That's how Facet grid works. And so what you've done is you've broken the data down into 6 pieces. This piece where I'm waving the map is all the days that were spring days that were Monday through Friday. And same for the other 5 pieces. So looking at these density plots, you could draw some conclusions. For example, it looks like the volume is kind of low in the fall, like it tends to be around 300 or so on Mondays and Fridays. It's not quite so low on Saturdays, Sundays, because those are weekends and people go out to watch the turning leaves or something. The volume in the fall on a weekday is less than the volume in the summer on a weekday, because the summer is more like around 400 or so. So you can learn those things by looking at this plot, but it's a little bit hard to work with all these density plots at once. A little bit too busy. So let's try another one. Maybe we should just have one row, one for each of the seasons across 3 columns. So let's take a look at what I'm going to aim at. So I've got spring, summer, and fall. And in spring, I'm going to be making 2 box plots, one for the weekdays and one for the weekends. On the y-axis is volume, same idea for the summer and for the fall. And it's a lot easier there to start making some comparisons. So you can see in the spring, the median volume is much higher than the median volume in the weekdays. In summer, the two are about the same, which kind of makes sense because in summer people are sort of on break and on vacation more, so it doesn't matter so much as whether or not it's a weekend in their decision to go out onto that trail. In the fall, they're back at work again, and so you can expect more people on the weekend than on the weekday. And you can also make comparisons across seasons. Fall weather is colder, so the volumes tend to be lower than maybe the summer. So that's a nice graph that strikes a good balance between the faceting into the 3 separate plots and apparently some aesthetic mapping going on within each plot, where the exposition got mapped to type of day. So let's head back and see how that's created. So in the setup, we're aesthetically mapping X to weekday and Y to volume. Geom box plot fill equals weekday just gave the different colors for the 2 different plots. We're trying facet grid again, but we only want to vary by season. And so the dot before the twiddle says we're only going to have 1 row. And the columns will vary by season. We got our labels. And just to show you that you can do it, you can modify anything you want in a ggplot. Here I am using the theme function to say that the legend ought to be on the top and that the different values in the legend should be laid out horizontally, like you see here, Monday, Friday, then Saturday, Sunday, horizontally instead of a vertical legend. How about facet wrap? You use facet wrap when you only want to split up by a categorical variable that has lots of different values. So to show you an example of that, take a look at CPS 85 in the Mosaic data package. So let me get help CPS 85 and have a view of it as well. So what we learn is that this data set is a little selection from the current population survey done back in the year 1985. There's about 547 people in the survey. Each row is a person, and they gathered information about the person, their wage in dollars per hour. And if the person was a salaried person, it was converted to dollars per hour. How many years education the person had, their race, I think is put as either white or non-white. Sex, M or F. Hispanic was either NH for non-Hispanic or HISP for Hispanic. Whether or not they're from the South, whether they're married or single. Experience is some constructed variable that kind of comes from their age and some estimate of how long they've been on the job. Whether or not they belong to a union, their age, and importantly, what sector of the economy they work in. Is it cons, construction? Is it sales? Is it clerical, like administrative assistants and sales clerks? Or is it manufacturing? Prof is not professor, it's any kind of professional like doctor, lawyer, or professor. Service, and then there's an other category as well, and sales and management. It turns out there's 8 different sectors. Okay, back to the slides. So why don't we do this? Let's study the ages of employees in the various sectors of employment. In the homework, you'll get some more interesting problems to work with for this data set. So a suggestion might be, we're going to make density plots where we make one for each of the different sectors. So since it's a density plot for the ages, we set up the frame, X is age, leave Y alone, and R will use that for the units on the density plot. We make density plots, colored burley wood, or any color you like. And then we head to facet wrap. And it needs a twiddles and then the variable that you plan to facet by. Now you can control how many rows are going to be in that facet with an in-row argument. And so we get this result, 8 different density plots. It is still a little bit difficult to compare the ages of the people in these 8 different groups in this way. So as an alternative, you might want to instead try an aesthetic mapping. You don't want to overuse faceting. Aesthetic mapping can often get you what you want more clearly. So why not just do, say, box plots? We're going to map X to sector to be the grouping variable, Y to be the age. And that really makes it much easier to compare. And you'll see that people in construction on average are, older than, say, people in manufacturing or in the other category. Just a couple of little things to point out when you're doing the code for ggplot. First of all, try to live a little. Exercise your options with things like what kinds of aesthetic mappings you want to make and what kind of fixed properties you want. I mean, don't get ridiculous, but play around with colors a little bit. Here's fill equals sky blue. You can use any named color you like from the colors function in R and just put it in for the fill and see if you like the result. Another, and this is the more important thing to keep in mind, the most common error you're probably going to get when you work with ggplot, and this happens to experienced people all the time, is a failure to call an aesthetic mapping when you meant to. So here we are trying to make that scatter plot of Facets versus GPA, where we would like to break down color, we would like to aesthetically map color to sex. And so we say geom point, and we say color equals sex. And we run this, and we get this error. Error in blah, 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 technical. Object sex not found. What happened here? Well, when ggplot saw color equals sex, it did not see it wrapped in a call to S. So it says, I guess they're not doing an aesthetic mapping here. They must be mapping color to this fixed property that's called sex. And since it's a fixed property, it figures that sex is not supposed to be like a column in Math 111 survey. It must be some variable up in a higher environment somewhere that it has to go looking for. And it goes looking and it doesn't find sex anywhere. So object sex not found. So when you see an error like that, check to make sure you've done your S calls. This would be the correct approach, as we have seen. Thanks for listening. We'll be back with another round of another screencast on ggplot soon.